In this video I would like to show the basic functionalities of the SpiderControl HMI Editor. If you are interested in using it on a specific PLC like Simatic or Beckhoff, so have a look at the specific videos which address especially this topic. If you want to make a new project, it's the easiest way to start the wizard. Give the project a name and store it to a directory. Next thing is to define the resolution of your HMI project in which you can edit it. Then we will define the refresh period. This will show how fast the variables will be read from the target. We can choose a style, so SpiderControl supports vector graphics, and the wizard will generate a couple of samples using this style. We can generate a couple of views, so that will be 5 which will be automatically generated. Then we will use this multi-layer capability of SpiderControl, so we have a foreground and a background layer. So the background layer can provide a navigation pane for the buttons to navigate between the different views, and we have a foreground pane which allows for integrated pop-up messages and similar functionalities. Then we have a multilingual support, so we can generate CSV files for every language that will be supported. The login we will leave away. There is a specific video to show exactly this. So the wizard has now generated this project, which we can see on the left hand side. We have the background, foreground and 5 views, including some basic functionalities. We can here insert objects. Here on top we have our standard HMI objects like static text. So this text will simply display something. We have multi-line text, we have ovals, rectangles, etc. We have an edit field which allows for an editable variable to write the variable. We have buttons. The buttons will be inserted using the selected style. So on the start side we can select different type of styles. We can, for instance, change to glossy style, and when I integrate the button it will appear using this style guide, this style library. When we select such a object, then we have on the right hand side the property pane, which shows us the most important functionality. So we have a general folder which shows position, color, font type and such things. Then we have the repaints section. The repaints define what the object actually shows on the display. We have several possibilities here. So the first is a PPO. This is a process point, a variable which comes from the PLC. So this is read from the PLC. This is the live value. We have container variables. These are local variables which are just have their scope in the local HMI, so this can be used to exchange variables between objects. Then we have the HTML tag. This is the language resource. Everything which I define as an HTML tag can later be translated through the CSV files. And the string is a general constant. This can be a binary, an integer, a float, or just a text. So to create a title, I will choose HTML tag and enter the title text directly here in the repaint properties. I will change the font in general properties to a larger size. can change the outline color, so this will change the text to red. We go on to the edit field. The edit field is basically the same like static text, but allows me to also write to this variable in runtime. So what I can choose here is just PPOs and containers, because these are the variables I can write to. We have also the password, PPO and container variants, so this will show only stars in the text field, so the text will not be visible when editing it. Then we have possibilities to change colors during runtime. We have some text position options: left, middle, right, top, middle and down. Then there is other options to display a multi-line text. We can specifically change text colors in functions of a condition. We have the possibility to move an object in X and Y direction using a variable, which can be a container or a PPO. We can hide and disable conditions, so a hide on a condition will let the object disappear. So we can choose a container variable as a source and compare this variable to a constant. And we say, well, if the constant is 1, if the container is 1, then it will be hidden. Additionally, we can make a disable condition, so disable will forbid the object to be written to. It is visible, but I cannot change its value. I will put the same condition. We'll add a second edit field to display this container variable, which controls the editability. So this will later show us how it works. Now we go over to the button. We have several repaint possibilities, so the object shows first of all this image, the vector graphic, which shows this little house. To change this graphic, we can press on the star object and it will show our graphic library, and we can select a different object from the library. The second repaint on this button will show this text, so we can modify the text accordingly. Then there is the possibility to use different skins for the pressed state and for the disabled state. So then we will move over to the actions. So what will the button do when pressed during runtime? We can write a variable on mouse down. So in this case we would like to write to this container variable is visible the value 1, which will make the object disappear. There is other possibilities to toggle a value between 1 and 0, or to increment and decrement a variable. We also have jumps, so I can jump to a different view. This object is used here on the background layer, which was generated automatically, so each of these buttons will jump to one of these 5 views, and here I can change the destination the button jumps to. So this allows for a very simple way to create navigation. This action here will cause a jump back to the last page where we have been, and this action here will initiate an URL jump to a different HTML page on the same server or on another URL. So on this button, which has a different style. Let's have a look how it is constructed. So the first repaint action will use a vector graphic for the orange background. The second edit will place the arrow on top of it. This button also uses a skin for the pressed state, so this will show the image in an inverted kind of style. And we have a disabled skin, which will show the button grayed. We can also add runtime actions, and in this case here we will use the toggle functionality to this is visible container. So this button will allow us to toggle the visibility of the edit field above. Okay. Additionally, these vector graphics which are used in here allow us to change their properties. So in this case, for instance, I can change the colors of this gradient. So if I want instead of orange something which is rather in a bluish style, I can just directly modify this here. I can also modify the alpha channel, so define an opacity of 70%, for instance, so we'll see that it becomes semi-transparent. So we have full control over these features. So we'll now go and test the HMI which we created so far. We start the integrated simulator. It will compile and start our HMI. So we have possibility to navigate. I can enter a value in the edit field, and with our action I can now hide and disable by toggling the value with this button. So this button will write just a 1 and makes it invisible, and this one makes a toggle and makes it visible again. We have here the possibility to change languages. So these are the first basic explanations of SpiderControl and property pane. If you want to see more complex things, please see the other two videos which are also relating to basic functionality of SpiderControl HMI Editor.